Hello everyone, welcome back to Stud Eye. Today we are going to discuss that how can we calculate the power of the lowvision aid, which is the spectacle magnifier. So spectacle magnifier means that a magnifier which is built into the spectacle, right? Or we can simply say that it's a convex lens which is used as a lowvision aid for the lowvision person. So spectacle magnifier is a type of lowvision aid that helps a person to see the near object clearly, right? So in the spectacle the convex lens is placed which helps to magnify the near objects clearly, which is basically the spectacle magnifier, and it is of high power. So it has high power in order to enhance the near residual vision of a low vision person so that he can see the near objects clearly, right? So how can you calculate the power for this spectacle magnifier? So I have been telling you in each and every video regarding to the low vision aids that if you are using any kind of low vision aid, you have to choose or select the power or magnification of that low vision aid for every patient, right? So what I mean is that for every patient the low vision aid power and magnification will vary, right? So you have to calculate these powers and magnification with the help of some formulas, and I have discussed the videos regarding to the low vision calculation, which were, one was the calculation of the magnification for the handheld magnifier and for also the magnification calculation for the telescope. So today we are going to discuss about some other low vision aid type, which is the spectacle magnifier. So we have a case that a low vision patient comes to you and you have to provide him any aid. So whenever a low vision patient comes to you, he does not want any treatment, he wants the low vision aids. His now will is to enhance the residual vision of his eye. So for that cases you have to see the all history or the past history of the patient, and you have to prescribe the best corrected or best or more closed low vision aid for that patient, which will be more suitable for him, right? Okay, you have done the refraction, you come to know that best corrected visual acuity is 636 with the help of +3 sapphire and -1 at 90 degrees cylinder. So this is the correction of the patient which he uses, right? And for near, after using the M notation, the patient's visual acuity for the near is 3M at the 20 centimeters, right? And he wants to read 1M notation font letter or 1M line on the M notation chart at the distance of 10 centimeter, because he says my laptop work or my mobile work or my document work, any work which he does or he wants to do at the near requires the font size of approximately 1M line and at the distance of 10 centimeters. But his actual near acuity, because of any kind of reason which made him a low vision patient, gives him about 3M at 20 centimeter vision. So according to his requirement, we can prescribe him any kind of low vision aid. So after seeing his requirement, we came to know that patient can use spectacle magnifier in order to see the close-up objects clearly, right? So our low vision aid is spectacle magnifier. So for spectacle magnifier, we want to calculate that how much power of the spectacle magnifier should be given to the patient, because in the spectacle magnifier we are basically using a convex lens that helps the person to magnify the near objects, right? So it's a property of a convex lens to magnify the image. So for this kind of patient who wants to see the near objects clearly, we can give him the plus lenses, which is the convex lenses. So how much power of spectacle magnifier should be given to the patient? We have to calculate it. So for this you have to know the formula, which is EVP, and other name of EVP is equivalent viewing power. Equivalent viewing power is the EVP, and it is the power of the spectacle magnifier which should be given to the patient, right? So EVP, if we have to find this EVP, which is the power, equivalent viewing power, it means that how much power should a patient have to see the line or to see the 1M notation, right? So EVP equals to 1 over EVD multiplied by 100, where EVD is the equivalent viewing distance, or it is the distance at which this power gives the good vision. Over here, for the calculation of EVP, we also need EVD, but which is the equivalent viewing distance, which is unknown. So for EVD, we have another formula, which means that actual near viewing distance divided by ER. But over here we also don't know which is ER is the equivalent ratio, right? Or it means that how much magnification should be given or should be needed for the patient in order to see the image clearly. Enlargement ratio means how much magnification of the image is required to see clearly. So ER is also missing, so we have to first know what is the value of ER, so that we can know that what is equivalent viewing distance. And when we came to know about equivalent viewing distance, we can place the value of EVD into the formula, which is the main formula, that is equivalent viewing power equals to 1 over EVD into 100. So over here enlargement ratio is also unknown, whose formula is enlargement ratio equals to actual letter or actual near size divided by desired near letter size. So over here actual letter size was 3M, while desired or the letter size which patient wants to read is 1M. So you have to divided by 1 in order to know the enlargement ratio. So over here actual letter size was 3M and desired letter size is 1M. So you have placed it into the formula, which is enlargement ratio equals to actual letter size divided by desired letter size. So 3M divided by 1M equals to 3. So enlargement ratio is 3, and ratio does not have any unit. So we came to know about enlargement ratio, which is 3. So we can place the ER into the formula of EVD in order to find the equivalent viewing distance. So EVD equals to actual near viewing distance divided by ER. So over here we have to use actual near distance, which is 20 centimeter. So 20 centimeter divided by ER value, which is 3. So now over here we obtain EVD equals to, which is equivalent viewing distance equals to actual distance, which is 20 centimeter, and ER, which is 3. So we obtain EVD equals to 6.67 centimeter. So now after knowing the equivalent viewing distance, we have to calculate, basically we wanted to calculate equivalent viewing power of the spectacle magnifier, but we were unable to know the value of the equivalent viewing distance. So that is why we did the previous steps. So now equivalent viewing power of the spectacle magnifier equals to 1 over 6.67 multiplying it with 100, you obtain EVP equals to 14.99 and EVP equals to approximate for 15 diopters. So this is the basically power of spectacle magnifier. So EVP equals to 15 diopters. But this doesn't end over here. You have to see that either the patient use any glasses or not. So over here you can see that before moving to the low vision aid, you have been told that patient already uses a glasses in order to see the distant object clearly, or in order to have the visual acuity of about 636. So over here you know that patient is already using this prescription. So what will now you do? Always remember that you have to ignore the cylinder for the low vision person, and you have to make your focus on the sphere. So what I mean is that you come to know that equivalent viewing power of the spectacle magnifier is 15 diopters. If a patient is not using any glasses, this will be the final power of the spectacles you are going to prescribe to the patient. But if patient is using any prescription, you have to note that prescription. So over here you can see the patient is using glasses which was of about +3 -1 at 90. -1 at 90 was the cylinder which you have to ignore in the case of low vision patients, right? And your focus should be on the spherical power. Now what you have to do, that if patient is using any prescription, you have to ignore the cylindrical number and focus on the spherical number. How you are going to focus on the spherical number? You have to algebraically add the equivalent viewing power with the spherical power in order to get the actual power of the spectacle magnifier. So algebraically adding EVP with the spherical power, you obtain +15 + 3 equals to 18 diopters. So this is the actual spectacle magnifier power, right? So power of the spectacle magnifier will be +18 for this patient, right? So again, if a person is not using any kind of glasses, this will be the end point. But if he is using any kind of glasses, you have to ignore the cylinder and you have to algebraically add the EVP into the spherical power, and the final answer after the addition will be the power of the spectacle magnifier, right? So this is all about how you can calculate the power of the spectacle magnifying glasses to the low vision patient. In case of any problem, you can comment in comment section. Don't forget to like, subscribe and share it with your fellows so that they may also know that how you can calculate the power of the spectacle magnifier. Thank you so much.